Hello.
Hello.
Okay, let's start again.
Am I doing the intro again? Am I starting? I thought, okay. Vervi. G'day. Kia ora. Hi, I'm Bruce from Kai's Clan, all the way from New Zealand. I'm the founder, and welcome to today's session. And we're lucky to have Ranel Schott and also Alicia Vervi from Mississippi in the United States. So thank you for joining us, Alicia. What have you got?
We won't hold it against him. He can't say y'all either, so it's okay.
You all.
It's her, we.
Yeah, but can you say g'day, mate?
Oh, good day, mate.
And that's Australian. That's not
that's
New Zealand.
not New Zealand. That's correct. Okay, so Alicia, what have you got planned for us today?
So today, Bruce, we want to look at how we can use data in the classroom and make it real for kids. Really give them that understanding and grasp of how to dig into it, what they can do with it inside of a gamification setting, but also how to bring it to life in the classroom and do different things with it once we extract it. So we are going to fast forward a few years and pretend that it is now 2040. We are going to be on Mars. And for those of you that are not familiar with Kai's Clan, oh great, there's an image of the Mars mat, and we've got our Kai's Clan robots on the mat. So just like in our world, we have run into some issues on Mars. And so we're going to be addressing 3 issues in 3 separate activities dealing with the sensors that you can connect to the Kai bots. So what we are going to do for activity 1 is we are going to be measuring our light. And we're going to do this by doing plugging in the light sensor. So Ronell's showing you what the light sensor is going to look like there. And it is very simple. You get this sensor and it plugs in with your little cable. There's a green connector, just plugs directly into the back of the robot there. And she's got robot 1. And we're going to measure how much energy that we get from the sun on Mars using our light sensor. And so we are pretending that we have a solar farm set up, and this amount of light is going to adjust based on the amount of sunlight that exists, just like it does in our world. You know, the sun is up and then it sets, and so you can emulate this. They've got a cute little solar farm set up there for you with the QR code, which is how it's going to read that icon. And you'll see in a minute, we'll go onto the platform and you can see how that icon becomes gamified in their virtual world. But basically what you want to do is have some sort of light source. That can be a heat lamp, that can be just a regular lamp, and you can shield that a couple of different ways. You can have like a black piece of construction paper, you can use your hand, but you want the light to come and go based on how the sun would really do in the real world. So Bruce, can you jump in and let's show them in the platform what this is going to look like? So you've seen the sensor, it's plugged into the bot. And then inside of the platform, you'll see the gamification features. You've got the mat. We're going to show the viewer in a minute, but down below the mat there, you see that the data is reading. So what's going to happen is students will program the sensor to read in real time. And so Bruce is going to show you that here on the screen.
So I'm just going to drag that into a loop, and I'm going to go to bits. So bits is where all the sensors stuff is stored, and we're getting the light sensor, and that light sensor is connected to robot 1. And if I'm just going to print that to the log, a console log, and if we open that up, now if Ranel moves her hand over that sensor, you'll see that data going up and down.
And so you can see it's collecting that data in real time. Now, what is happening is you are logging it in their platform. And now, Bruce, will you show them? You can easily then take that data and export it into either a Google Sheet or an Excel spreadsheet. And as you can see there, it's as simple as the click of a button. And now you have this data at your disposal, so you can either take this data and create different problems for the students, for them to solve. The students can take this and then graph that data. So there's so much that you can do with it. And because it is data that they collected, this data now has meaning to the students. And so they're much more excited about engaging with this data than just any old random worksheet data that you give them to work with in class.
But Alicia, why don't we have a look and see how we can actually use these physical sensors to affect a virtual world?
Yes. So if you'll go back and you show let's show them the virtual viewer. And as I mentioned before, this gives that gamification factor to it. We all know students love playing video games. And so now you see the virtual viewer over on the right side of the screen, you see the mat and you're able to see the bots. And then those bots are translating, and the QR codes that are set up are translating into the little characters that you see here in the virtual world. So show them the bot with the light sensor and the solar farm.
So what we've done here is we've actually called this light sensor as the student name. So that's how you're seeing light sensor come up on this robot 1. So when we move the robot, you see the virtual robot move as well.
So you can see it move around. The kids see that and they get very excited because it can become whatever they want it to be. They can create their own characters here, so they can make their robot look any way that they choose.
And I think some of the fun things as well is adding some of the sandbox gamification elements to it. So why don't we have a look and see, Bruce, if you can load some of the code that's going to make our solar farm shrink, grow smaller and taller when we change the light. So if you go back onto the code blocks, you just need to find the project. So projects, we've got 65 different lesson plans on the different mats, but we're going to look for Mars, dig for data.
Now the nice thing about this is they're going to show visually to the students how when those percentages get larger, visually on the screen something gets larger. When those percentages get smaller, then visually on the screen those percentages get smaller. So they're really making those connections between the physical and the virtual worlds, and making it make sense.
So here we've got so we do also have these QR codes laid around the mat, and we've also got object number 100. So each object, each QR code's got its own ID, and here we're going to say scale this object X, Y, but on its Z we're going to use the light sensor to scale it. So if we just run this code, and we're looking for object 100, which is this, which is our solar farm. We're just getting our robots ready for our dig for data. They're just moving into position.
Should be on the other side there.
Okay, so now our light sensor is reading. So we've got 81% of light currently coming through, and if we block that, now you see the building shrink because the light sensor value has dropped down. Actually, if we show the value, the light sensor is 14%, so the building is only 14% high on its Z axis, on its height axis. And if we remove that,
those little sparkles and stars, you can have animation and all sorts of things that you can add to those virtual objects. And this is where the kids are going to have a lot of fun using Minecraft and Tinkercad to go and create their robot avatars or their objects.
Yes. Yes. And Bruce is talking about the X and Y axis. If you look at the mat image over to the left above where the data is, you'll notice that all the mats have grids. So they're set up for X and Y axis coordinates.
So X is the left and right, the red axis here, and Y is the up and down, and Z axis is in the virtual, which is our height of how high something is. And we can actually click on the object. So there's our solar farm 100, and we get the angle of the object and its X and Y position.
So kids are just getting data from every different perspective here as they are going through the different components and the different features. So they're having to work with the data as they plug it into their code. They're having to understand data in terms of, plotting it onto the mat and the location that they want it to be at. And then, of course, the data that they're getting from the sensors that they're using. And so we have now, read our data in terms of how much light we are collecting. So activity 2 is what is the result of those light changes? So as the sunlight changes and Mars heats up and it gets hotter, we have the ice that begins to melt. And we're going to track this with our moisture sensor. And so if Bruce, will you show the moisture sensor so they can see what that looks like and how it connects to our bot?
So that reads the amount of moisture across the two prongs. So that's basically recorded like a resistance. So if something is very conductive, like a metal ruler, then it will give you 100%. But if something's not so conductive, like our bodies contain moisture, but obviously Renelle's doesn't have any moisture because she's not getting anything when she puts her fingers across.
The moisture sensor, I'm still seeing the platform.
Yeah, you're seeing the platform and the moisture sensor from our side. It's okay, we're recording the screen.
So now okay. 36% when I dunk it right into a glass with your moisture sensor. So how would that look in a graph? Would you export that the same, Bruce?
Yeah, you simply just go to the Excel icon or the Google Sheets here and simply dump that down to the spreadsheet and then go and graph that.
So I'm going to put it back on the ice, and then we can maybe talk again about those virtual objects of the iceberg.
So this is going to change as the size of the iceberg changes, and your iceberg is obviously resembled by your glass and your ice.
That's right. So we've got some, so we just run this code. Now it's saying I've got an error in my code, so I just need to go and hunt that down.
So you need to problem solve.
Yes. It says, oops, fix highlighted errors. What errors do we have? Speech bubble, text robot 1, a pen, light sensor, bot avatar with background. What? Play effect stars on bot 100. Are you covering bot 100? Where is bot 100?
What's there?
It can't be seen. Bot 100. Let's try that again.
It was blank. There we go.
Oh, there we go. Okay, so let me just take that out now.
Let's put it all together.
Okay, so we'll run that now, and we're looking for the iceberg. So here's our iceberg. It's more of a pancake. It's an ice cream pancake. And that we've called the moisture sensor, you can see there. And as we put the sensor probe into the water, and you can see slightly on the video, the iceberg starts growing. So this is actually incorrect because we need some ice in there, Renelle. I'm going to go, while you guys go chatting, I'm going to go and get some ice.
I think,
So
yeah, because we have to reverse it, hey, we actually have to, when the ice melts, then the iceberg sort of needs to shrink.
exactly, needs to get smaller. And so this is a great way to really have kids doing that real world problem solving, making sure that that data correlates to what they're seeing and that it does actually make sense. And so as they are, recording all of this and again, taking in that data, then once again, that data can be extracted into a spreadsheet as he mentioned. And then being able to see this and it automatically connecting to the virtual viewer in that game related reality that the kids are used to. I think you're really meeting them on a completely different level as to where they are and from an engagement standpoint. This is where they want to problem solve and they want to make sure that data makes sense, right? So then we're going to move on to activity 3. So we've looked at light. We've looked at the reaction to that light, which is our moisture, right? More light creates more moisture because the ice begins to melt. And so then our last activity is we need to put out a fire. So unfortunately, we had some fuel storage units that caught on fire. And because we have melted our iceberg, we now have water to put out the fire. So the climate change caused the explosion or the fire to break out with the fuel tanks. And you can use the QR fire reflection. There's a card actually that you can load that object so that it can become visible in the virtual viewer. Ronell, do you want to show them
So
how they can?
so all I've done, I've just got a little QR code, and that is now represented as fire that's sitting on the mat. So what we're going to do is actually robot 7 is going to go and pick up the water bottle to go and put out this fire. So there's actually quite a lot happening, but I think one of the really good things is not every student has to actually code a robot. Some of them can just be in control of these QR codes and on the design elements. So it's really about collaboration. So do we want to run that code?
Yeah, I think before you run the code though, can you show them on the live mat what the physical components are that you have set up there so they can see how this is translating into the viewer?
Okay, so this little marker here is our fire. And if you can see that on the video, there we go. That's our little fire symbol. Then we've got robot 7, which is our fire control. That robot needs to go and pick up that melted ice. And you can see we've got a water bottle here. And that water bottle is represented as that little white object. And if we move that around, you can see it. That's our melted water, melted ice. So robot 7 is going to go and use its grippers and go and pick that up. And then we need to take that water over to the fuel storage. So you can see fuel storage over there. Here, that's our fuel storage. If we lift the camera up, there we go. A little Lego with a QR code on top. And you can see that in the virtual that's where the fire is going to break out.
And they're going to be using their variables, their if-then features.
Okay, so I'm going to move the fire. It has spread across Mars.
Sorry, it never rings.
So now you can see we've got a fire on the fuel storage. And the fire is now covered by that. So there's the fire, and we can see our fire control robot has collected the water and is now taking it over to the fuel storage.
Sorry.
So our fire control now is moving back, and the fire is out, and all stations are back to normal on Mars. So yeah, we successful mission there.
So what we've done is we've gone through multiple facets of the problem, and looking at the ISTE standards alignments, you're utilizing computational thinking. And we've done this in conjunction with solving problems, but also implementing the technology components to help develop and test those solutions. And then specifically, we've focused on the standard where we're collecting the data and identifying the relevant data sets so that we can then analyze it and then represent that data in different ways as we facilitate the decision-making and the problem-solving process.
So, Alicia, what age group would you use this lesson for, and what subjects?
This lesson could be used probably beginning, and of course this is going to vary a little bit depending on your students' prior exposure to coding and robotics, but probably generically speaking, you could go with anywhere from around 5th grade, which would be around age 11 or so, all the way through high school, just depending on how you set it up and how complicated you wanted to get in what you want the students to do with that data once it's extracted, is going to vary depending on how old of a student that you go with. And what I mean by that is if we're setting up complex problems that we want them to solve with the data that we've extracted, you could easily get into some very sophisticated problem solving with high school students, and have them set up scenarios with that data that they need to illustrate and represent problems there. If you're wanting just to kind of connect the basic dots and you just want them to understand and problem solve the basics and be able to collect that data and understand percentages and XY axis and amounts of light and things like that, you could easily do this with 5th grade students. You could connect this to science. Across the board, you could connect this in your math class. You could even do an XY axis unit with this lesson. Could be a spinoff from that. You could do, if you're doing high school, you might be doing a data and statistics unit. And again, that's where you would start dealing more with the data that you've extracted, and really honing in on that and make it a math lesson. So there's a lot of different directions you could take this in depending on how it needs to fit for your needs.
That's really good. And I think, one of the other features, obviously, we've sort of just seen Blockly, and often people think, oh, Blockly is just for elementary, but we've got the Python function as well, so they can always cross over and go and look at that same code or code it in Python.
Exactly. And sometimes it's nice for students to be able to switch back and forth when they're in the problem solving phase, especially if they're students that are just learning Python or they aren't as skilled in Python, to be able to go back and forth when they're now having to focus on something very specific, like something related to the data or related to a problem and what's occurring on the screen. Like, for instance, what we saw earlier where our iceberg was getting larger instead of actually getting smaller. To be able to troubleshoot something like that, if they're learning Python and you want them to code in Python, but then once they've done it and there's an issue, they can easily switch back to that Blockly, which sometimes makes that easier to do that problem solving.
And the classroom management, how easy is that for teachers?
Wonderful. You can turn things on and off. So if I want my students to be able to discuss, I have that feature. If I don't want them to be able to discuss, maybe I have some students that get a little rowdy and want to, say or do things that aren't appropriate in a chat situation. You can turn those features off. As you can see, there's a list of robots. I can easily assign robots. I can see, yep, right there. I can have them raise their hand so I can see if someone's having an issue. I can see all of that within the dashboard. I can also monitor the information specific to the bots, how much battery life and things like that that they have, all from one area. If I have a student who says, Ms. Verwee, my light sensor isn't working, I can easily look here and make sure that the light sensor's plugged in. Sometimes students don't quite plug everything in correctly. So if they didn't plug in, I can say, well, your light sensor isn't registering, so let's take a look at that. So you can see a lot of the features right there within the dashboard, and it makes classroom management very easy.
Well, I mean, we at Kai's Clan, we love having a lot of fun. So maybe if we look at that sandbox, because this is where the students can go and play a little bit with designs, they can go Minecraft or Tinkercad and even see the AR or VR.
Yes, absolutely. They love creating their own characters. And the characters also, are very easily represented and with the click of a button can be uploaded into the platform. So once they have decided on either a character that's already in there or a character that they want to design and upload, it's very, very simple to then implement that onto the mat.
Awesome. And the AR and the VR, what kind of VR can you use?
Oh, you can do VR goggles or headsets if you have those. You can use the AR component if you've got tablets, you can see that there. So you have a lot of different options. One of the things that I really like about Kai's Clan is that it isn't platform specific. So if you have Chromebooks, you can use Chromebooks. If you have iPads, you can use iPads. So it's really a very versatile product in the sense of it kind of works with what you already have in your classroom.
Awesome. So I think just to end is that we will be at ISTE and Alicia is going to join us there, and we hope that the teachers will pop over and come and join some of the activities and they can code their robots and move around. So we hope to see you all in New Orleans.
Yes, come dig into the data with us.
Get your Mars shovels ready.
All right, well, thank you very much
Awesome.
all the way from New Zealand, and we really want to especially say thanks to Alicia, and also do a mention for Heidi Williams, which has also been working in the background on this project with us, and yeah, we'll see you all at ISTE. Thanks very much.
Bye.
See ya.
Okay.
Let me just stop recording.
Of course, my house